Hello, pre-calculus students. Today we're going to talk about section 5.8, which is the law of cosines. Remember, we talked earlier about the law of sines. So you will need something to write with, maybe some highlighters, your notes, and a scientific calculator. Remember to pause the video as you're watching to try the examples yourself. So as we've been talking about different ways to solve triangles that aren't right triangles, we've talked about, how we have side, we had side, angle, angle, side, and then side, angle, the ambiguous case. So when we use the law of sines, it's one of these two situations. And sometimes, right, sometimes here we got two triangles or one triangle or no triangle. Sometimes side works. So today we need to talk about, well, what if I know all three sides, or I know two sides in the included angle? Then how am I going to solve the triangle if it's not right? So I know my copy did not come out that great here, but take a look at your notes. These are 4 different ways that we can look at the law of cosines. So we've done that activity in class where we derived the law of cosines, and this is what we end up with. So take a look and see what patterns you notice about these formulas. Okay, so where this had come from is like starting with different sides, given sides and different angles where we knew the information. What you might notice is if this is a little a side A, then this is angle A. And if this is a little b, this is B, and this is little c, then this is C. Right? And then if that's an A squared, then this is the B squared and the C squared. So you always have all 3 of them, the A squared, the B squared, and the C squared are all involved. But if the B squared is here, then this is A squared and C squared. If that's C squared, this is A squared and B squared, right? This it might even remind you of Pythagorean theorem, C squared equals A squared plus B squared. They all have -2 and then times this product here. So if this is a B squared and C squared, here we see BC, A squared and C squared, we see AC, right? A squared and B squared, we see AB, and it's always a cosine. So we call this the law of cosines. Now, rather than having to think, oh my gosh, I have to memorize 3 different rules, in general, the one that you will sometimes see instead is just to say C squared equals the A squared plus B squared. That's kind of easy to remember because it reminds you of the Pythagorean theorem. And then that -2AB times the cosine of C. Now, when you're using the rule, though, because sometimes, like I'm looking down here just at a glance, and the angle I'm given isn't C, we just always rename whatever our given angle is as C. So this C is our given angle. This is always, this little c is the side across from the given angle. Okay, so let's take a look at the first example. So go ahead and read it. I would sketch a picture and then see if you can maybe get that started. Right, so suppose you want to fence a triangular lot if 2 sides measure 84 feet and 78 feet, and the angle between the 2 sides is 102 degrees, then what is the length of the fence? Okay, so I know this. So I need then to find the third side, which I'll just name C because it's what I'm trying to find, and this is the angle I have. And then once I have that, then I can add them all together to get my perimeter. It does not matter which you name and what A and which you name B. So I'm just going to call this A, call this B. Again, makes no difference. So I'm going to plug into this formula. So side C is what I'm looking for. And then I'll have my A squared and my B squared -2 times A times B times the cosine of my given angle. So my 102. All of these are numbers, right? I don't have no variables over here at all. So I could put that whole thing into my calculator all at once. And that's really the easiest thing to do, just so sometimes people just make little mistakes with just arithmetic if they just write down each thing separately. So I find that just putting it all in once, it makes it less likely. Okay, so I'm going to put all this in. Cosine 102. And then I get this 15,864.47 and so on. I can write that down. But that's C squared. I really want to know what C is. So I'm going to take the square root of that. So I'm going to hit Control squared to get the square root. And then to pull the answer down, you can either arrow up to highlight that answer and then click Enter, and it will pull it down. or you could hit control and then the negative sign, and that will pull your answer up. So then C is I just call that 126.0, right? The 9.5 would bump it up to the next whole number. So that's my C is 126.0. And then we were asked for the length of fence, so basically our perimeter. So we would add all of those guys together and get 288 feet. Okay, so example 2 gives us 2 different triangles and it asks us to solve each of them. So that means find missing sides and angles. So let's get that sketched. All right, and did you guys notice here that this was what we were originally given was side, angle, side, right? 2 sides and the included angle. So that's going back to what I talked about before with all the triangle congruence rules. That's the side, angle, side. And this is going to be another side, angle, side. Okay, so if I sketch this, so let's say this is my A, 39.4 degrees. I don't know side A. I know B is 12 and I know C is 14. And a lot of people ask me, well, how do I know? Could I use law of sines here? I like law of sines seems like a shorter rule. But notice, you know this, the only angle you know is this one, and you don't know the side across. So you wouldn't get anywhere if you try to use law of sines, because then if you did like sine of B over 12, you have 2 unknowns. So people will always ask me, well, how do I know law of sines or cosines? I personally always try to do law of sines first because it's easier to me. And if that doesn't work, then I know I have to do law of cosines. Okay, so I'm going to start by finding this side across from my angle. So that's going to be a squared equals my other 2 sides. So 12 squared plus 14 squared. So those guys squared minus 2 times the product of those sides. Oh, I wrote my one like that. Times this cosine of the angle across. So 39.4 degrees. All right, again, I can just put this whole thing into my calculator. So I could just do, if you want to be fancy, you could put the square root in, because you know after you do the 12 squared plus the 14 squared minus 2 times 12 times 14 times the cosine of 39.4, you know you're going to have to take the square root. So you could just do that if you wanted to. All right, so then I'm going to take the square root and I get 8.96. We usually round to the nearest tenth, so that would be 9.0. So that's my side A is 0. Now I need to get the remaining angles. It's not a right triangle. Wait, what do I need to get? Yeah, the remaining angle, sorry. It's not a right triangle, so I don't know that one of them is 90. So I'm going to use the law of sines, because now look, I have a pair, right? I could do now the sine of 39.4 over 9 equals the sine of your pick. Makes 0 difference. Okay, B or C over the side across. So I'm picking B. You could have picked C. It really makes no difference. And then I'm going to go ahead and solve and cross multiply, right? So I would have 9 times the sine of B equals 12 times the sine of 39.4. I would divide by the 9. I'm left with sine of B equals whatever that funky decimal is, right? So it's 0.846. And then I have to take, like we talked about last time, or a couple times ago rather, no last time, take the inverse sine, right? You want to make sure this goes out to at least the nearest thousandth. Don't just round that to 0.8. Take the inverse sine, I get 57.8 degrees. And then all that I have left is to find C. And because I have A and B, I could just take those away from 180. And that would give me my angle C, which is 82.8 degrees. Okay, so here's my C, here's my B, and up here's side A. Okay, so these kind of seem long, but it shouldn't be too bad. All right, so now let's take a look at B. Now B, this was another side angle side I was given, side angle side. This, I'm given 3 sides. So this is going to be an example of side, side, side. So I'm going to just sketch my triangle. I try to draw it sort of so that the side, so this is my B, and this can be my C. This is my A. Okay. The big thing here is you always need to start with the biggest angle that you find first. You find the biggest angle first. And the way you're going to know that you're finding the biggest angle is that the biggest angle is always across from the longest side. Okay, you need to do this to avoid having a two triangle side-side angle situation. Okay, so remember we talked about that in the last section where you, like if the one side is bigger than the other side or whatever, how you can have two triangles by starting with the biggest angle first to avoid that situation. And so in my case, my biggest side is the 24.3. So I'm going to start by finding angle B. Okay, so I'm going to have 24.3 squared equals my other two sides squared minus 2 times A times C times the sine of B. Now this one is a little bit more complicated to solve because I have a variable over here. Now what some people want to do is they want to put all of this into their calculator at once and then slap a sine of B at the end of it. The thing is, like this is all one term, and this is a term, and this is a term. These two are like terms because they don't have a variable on it, but this is not a like term because it does have a variable. So this whole business here is separate from these. Now, what I do to make this a little bit faster, like writing things down wise, is I try to use my calculator to help me. So I know I want these both gone off of this side. I'm going to subtract them over here all at one time and put that into my calculator all at once. So the way I wouldn't even write that down, right? I'm trying to save myself some steps. I would say, okay, I've got to do 24.3 squared minus 19 squared minus 21.8 squared, and I get negative 245.75. So negative 245.75. Whoops, I forgot the 5. Negative 245.75 equals. Then I would figure out what this product is, right? That's going to be my coefficient on the sine of B. So I'd have negative 2 times 19 times 21.8, which is negative 828.4. You guys, I wrote sine. It's a good thing I caught that. How many of you have been screaming at the screen? It's cosine, it's cosine. Good thing I caught that. All right. So it would have been bad. So I have negative 828.4 times a cosine of B. And then I want to get the cosine by itself. So I would divide. So the 245.75 divided by the 828.4. And I get that the cosine of B is 0.297. And when I divide that, I get 0.297. So if you were worried, oh, wait, I've got a negative, but then you had another negative, and then it ended up being okay. All right, so then I'm going to take the inverse cosine of my answer, and I'm going to get that angle B is 72.7 degrees. Okay, so I know B is 72.7 degrees. Now, to get A and C, you could, to get one of them, go through this again with another angle and side and do that whole business again. Or now that I have an angle on the side across, then I can go for the law of sines, which to me is just way faster than the law of cosines. So I could do the sine of 72.7 over 24.3 equals, go ahead, it doesn't really matter now, sine of A over 19. And then cross multiply and solve. So 24.3 sine of A over 19 sine of 72.7 divided by the 24.3. And I get that the sine of A is 0.747. And then take the inverse sine of both sides. And I get 48.3 for angle A. So this is 48.3. And then finally, to get angle C, I would do 180, and I would take away the 72.7 and the 48.3 and get 59.0 degrees. So when you have to find the angle, the law of cosines does seem a little bit longer to solve than it did when it was just the side. All right, now the last thing that we're going to talk about is an area formula based off the law of cosines. I'm not going to go through and derive it like we did with the law of sines. It's written down here, and you could always use the law of sines if you wanted to. Remember, we had those rules like area is 1/2 AB times the sine of C. So I could, if I wanted to, if I draw this out, I could say, all right, well, I know if I use the law of cosines to find an angle, I have to find the biggest one. And what I could do is I could find out what this angle B is using the law of cosines, and then I could plug into this rule, right? If I'm using this angle, it's really more that I'm doing angle B, and then these are sides A and C. Okay, so that would be one way that I could do it, is I could find this angle using the law of cosines like we just talked about, and then I could plug in these two sides and that angle, and I could get my area that way. Okay, another way is if I know all three sides, and I know this came out lousy again. If I know all three sides, there's another formula for the area of a triangle. So it's the square root of S times S minus A times S minus B times S minus C, where S is called the semi-perimeter. Perimeter is where you add up all three sides. Semi means half, so semi-perimeter is half the perimeter. This is a formula that you can use if you know all three sides. Now, if I put on a test or quiz that you have to find the area of something and you're like, I can't keep two formulas in my head, I'd rather find all three sides and use this formula, or I would rather use law of sines or cosines and use this formula, then that is perfectly okay. I'm going to show this formula just to practice. Okay, so for this, the first thing I would do is I would find the semi-perimeter. So I would add my three sides and then figure out half of it, which is 57.5. And then to get the area, I would just do the square root of, so it's S, so 57.5, times the product where I find the difference between S and each side. So 57.5 minus 24 times 57.5 minus 52 times 57.5 minus 39. I would put that whole thing into my calculator all at once, and you end up with 442.7 square units. Okay, so that's just an alternative formula for area, right? And then just go ahead and try that last one. So again, I would find the semi-perimeter. So I would do half of 47 plus 53 plus 44, and I would get 72. And then for the area, I would do the square root of 72 times 72 minus 47 times 72 minus 53 times 72 minus 44. Again, I would put the whole thing in my calculator all at once. You get 978.6 square units. Okay, so now we've talked about how to solve any triangle, not just right triangles, but any triangle. And no, it doesn't matter what information we're given, right sides or angles. We know how to solve all of our triangles. And that's it for 5-8.